video we're going to look at Pythagoras Theorem. So we will state the theorem and then we will use it to solve a few questions. So the theorem is that for any right angled triangle we have, well, let's first draw a right angled triangle. So we'll take a general diagram of a right angled triangle. You can see we've got three sides, two of them which meet to form the right angle we'll call A and B. These are always the two shortest sides in a right angled triangle. They don't have to be the same length as each other. You can see B here looks longer than A, but they're always shorter than the third side, which is side C in our diagram, which is called the hypotenuse. So C is the side opposite the right angle. It's called the hypotenuse. So this is an important bit of terminology. Whenever we talk about the hypotenuse of a right angled triangle, we mean the side opposite the right angle. And that's always the longest of the three sides. So with this setup, Pythagoras' theorem is that a squared plus b squared equals c squared. So it's this equation here that is the theorem. It tells us that the sum of the squares of the two shortest sides, the sides which form the right angle, equals the square of the longest side. So if you know two of these values, you can plug them into this equation to get the third one, which is exactly what we're going to do in our problems. So let's try this first example. Find x in the following diagrams. So here is our first example. We have that the two shorter sides of this triangle are of length 8 and 6, and we want to find the hypotenuse x. So we simply plug into Pythagoras' theorem and we get that 6 squared plus 8 squared equals x squared. And from this point on, we just work out these numbers and then rearrange a bit to get x. So 6 squared is 36 and 8 squared is 64. So we have 36 plus 64 equals x squared. That's 100 equals x squared if you add them up. So now we take the square root of both sides to get x. So x equals the square root of 100. If we take the square root of x squared, the square root cancels with the x squared, which is why we just have x. And then square root of 100 is 10. Hopefully you know that, or if you don't, you could put it into a calculator. So we found the length x of this triangle is length 10. As I said, always the longest side, and that's confirmed here. Okay, let's try another example. So this time we're given one of the two shorter sides that make the right angle. We're given one of them is length 12, and then we're given the hypotenuse is length 13. So it's going to be slightly different. If we plug this in to our equation, what do we get? We get that 12 squared plus x squared, the value we're trying to find, equals 13 squared. So this is important to note. Sometimes you're given the hypotenuse and one of the other two are lengths, and you have to make sure you plug them in the right way. So now in order to find x, we're going to have to rearrange a bit more than we did the last time, but perfectly possible to do. So again, we'll work out these numbers. We get 144, that's 12 squared, plus x squared equals 169, which is 13 squared. We now rearrange. Let's take the 144 to the other side of the equal sign. That is, let's subtract 144 from both sides, so that it cancels on the left hand side, and we end up with x squared equals 169 minus 144, which is 25. So x squared equals 25. Once again, we take the square root of both sides and we get x equals 5, which is the square root of 25. And that is Pythagoras' theorem, and that is how you can use it to solve some problems.